Okay, so for this video, we'll be discussing about definite integrals. So suppose f of x is a continuous function along the interval from a to b, and also suppose that capital F of x is any antiderivative of f of x. So then, the integral of f of x dx from a to b is equal to capital F of x from a to b. So this is equal to capital F of b minus f of a. So what does this mean? So it means that when finding the value of a definite integral, so upon integrating, now we will substitute the values for b and a, no, and get their difference. Okay, so once we have the integral, no, of the function f of x, small f of x, then what we're gonna do is we will substitute b and a with the integral obtained, and then subtract, no, their values. So a special characteristic also of definite integrals, so after integrating, so we don't include anymore the arbitrary constant c, or the constant of integration. So because upon substituting, no, these limits, no, and then subtracting, the c's actually cancels out, no? So they so the c's cancel out, no? So most of the time, or most in definite integrals, so we don't include the c's anymore. So say for example, so to illustrate that, so we have an example. So the integral of 6x squared minus 5x plus 2 dx from negative 3 to 1. So let us integrate that. So integrating this, so we will have integrating each term. So we have a numerical coefficient 6, so write that, and then multiplied by the integral of x squared, so by the power formula, so that will be x cubed over 3. Okay, so minus, so we have another numerical coefficient 5, and then the integral of x is x squared over 2. Okay, and we have integral of 2 dx, so that is plus 2x. Okay, and to illustrate that the c's cancel out, so we will just write for this example plus c. Okay, and then write the limits from negative 3 to 1. So a, by the way, is the lower limit, and then b is called the upper limit. So simplifying first, so here we will have 6 divided by 3, so that is 2x cubed minus 5 halves x squared, okay, plus 2x plus c from negative 3 to 1. Okay, so what we're gonna do is we will substitute first the upper limit b, and then subtract it with the value of f of x at x is equal to the lower limit a. So that will become so we have 2, upper limit is 1, so all the x replace it with 1, so 1 cubed minus 5 over 2, 1 squared, plus 2 times 1 plus c. Okay, so minus, substituting negative 3, so 2 times negative 3 squared minus 5 halves negative 3 squared, so let's write it here, plus 2 times negative 3, and then plus c. Okay, so as you can see, so the two c's actually cancel each other out. So c minus c. Okay, so they cancel out. So therefore, so therefore, so it is okay if we don't write the constant of integration, no, after integrating here. So the c, we could choose not to write it anymore or not include it anymore. So by simple what do you call this, simple arithmetic, so we can use our calculators. So 2 times 1 minus 5 over 2 times 1 plus 2. So we'll have this one. So we have 3 halves minus, so this one, so we will have 2 times negative 3, sorry, this should be cube, so 2 cube minus 5 over 2 times negative 3 squared plus 2 times negative 3. Oops, is it correct? So negative 165 over 2. Okay, so if we add those two, so we have 3 halves minus negative 165 over 2, so that is 84. Okay, so that's how simple it is. So all we need to do is integrate and then substitute the limits, no, and then subtract value of f, capital F of x at the upper limit minus the value of capital F of x at the lower limit. Okay, so let's take a look with this other example. So another example, so we have square root of integral of the square root of t times t minus 2 dt. So to integrate this, we can express this in what do you call this, from radical to exponential form. So t raised to 1/2 times t minus 2 dt, limits from 4 to 0. So we can distribute, so we will have integral of t raised to 1/2 plus 1, so that is 3 halves minus 2t raised to 1/2 dt from 4 to 0. Okay, so integrating, so we can now integrate this. So this is t raised to 3 halves plus 1 over 3 halves plus 1 minus 2 times our formula for t raised to 1/2. So t raised to 1/2 plus 1 over 1/2 plus 1. Okay, so limits from 4 to 0. Okay, so simplifying, so this will become 3 over 2 plus 1, that's 5 over 2, and then that's 1 over 5 over 2, meaning it will be 2 over 5 times t raised to 5 over 2 minus, so we have here 1/2 plus 1, so this will become 3 halves. So 2 divided by 3 halves, that is 4 over 3. So 4 over 3 t raised to 3 halves. So limit from 4 to 0. Okay, so substituting the limit, so first the upper limit, so we will have 2 over 5 of 0 raised to 5 halves minus 4 over 3 of 0 raised to 5 halves. Okay, minus the lower limit. So we have 2 over 5 times 4 raised to 5 halves minus 4/3 of 4 raised to 5 halves. Okay, so as you can see, this will become 0, right? Those two are zeros. On the other hand, this one, so this first 4 raised to 5 halves, so that's square root of 4 raised to 5, so that is 2 raised to 5, so that is 32. Now times 2 over 5, that's 64 over 5. So let's check using our calculator. So I forgot that we have a calculator, so we have 2 over 5 times 4 raised to 5 over 2. Yes, I'm correct. That's 62 over 5. So we have negative 64 over 5 minus, we have, oh sorry, this is 3 halves. Sorry. Okay, so that's raised to 3 halves. So 4 square root of 4, so we have 8 times 4 over 3, so we have 8 times 4, that's 32. So 32 over 3. So let's check. So 4 over 3 times 4 raised to 3 halves. So that's 32 over 3. So minus 32 over 3. So using your calculators, so you have negative 64 over 5 minus 32 over 3. So that is negative 32 over 15. Okay, so next, number 3, we have this one, integral of e raised to 1/2 of x, e raised to 1 over x squared dx from 1 to 2. Okay, so if we rewrite that, that will be integral of e raised to 1 over x times dx over x squared. Okay, so as you can recall, so we have the integral of e to the u du is equal to e to the u plus c. So here our u obviously is 1 over x, therefore our du should be the differential of 1 over x, so that is negative dx over x squared. So therefore there's a missing negative there and then negative there. So therefore it's from 1 to 2. So therefore it's negative e raised to 1 over x. Okay, so limits from 1 to 2. Okay, so substituting the limits, so negative. So we have e raised to, for 2, so e raised to 1 over 2 minus lower limit, so e raised to 1 over 1. So therefore it's negative e raised to 1/2 plus e, or negative square root of e plus e, or you can also have it as e minus square root of e. Okay, So when you have irrational numbers, no, as fractions, as answers, so please retain the form. Okay, so don't convert it to decimals. Okay, so another. So we have so how do we solve this? So this looks like integral which leads to inverse trigonometric function, so particularly arctangent. So this will become, rewriting, this will become dx over so 4 is 2 squared plus x squared from 0 to 2. So it will become integrating this, so this will become 1 over a, so 1/2 arctan of u over a, so x over 2, limits from 0 to 2. So we will have 1/2 arctan of, substituting the limits, for the upper limit we have 2, no, over 2 minus 1/2 arctan of lower limits we have 0 over 2. So arctan of 2 over 2, so arctan of 1, that is pi over 4. So recall your trigonometry. So that is 1/2 arctan of 1 is pi over 4 minus 1/2 arctan of 0 is 0. So we'll have pi over 8. Okay. Okay, so for our last example, so we have here integral of secant squared of w minus 8 cosecant w cotangent w dw from pi over 6 to pi over 3. So as we can see, so both of the terms are direct use of the integrals of trigonometric functions. So we have integral of secant squared, that is tangent, and then integral of cosecant w cotangent w, that is negative cosecant. Correct? So we will have, so integrating the first term, so the first term is numerical coefficient of 2, integral of secant squared w, that is tangent of w, okay, minus 8, integral of cosecant w cotangent w, that is negative cosecant w, okay, from pi over 6 to pi over 3. Okay, so simplifying, so we will have 2 tangent of w plus 8 cosecant of w, okay, from pi over 6 to pi over 3. Now substituting, so we will have 2 tangent, so for upper limit we have pi over 3 plus 8 cosecant of pi over 3 minus 2 tangent of lower limit pi over 6, and then upper limit plus 8 cosecant of 8 cosecant of pi over 6. Okay, so we know that pi over 6 and pi over 3 are in radians. So using the unit circle, now we can derive the we can obtain the values now for the trigonometric functions of those angles. So we know that pi over 3, that is 60 degrees, and then pi over 6, it's 30 degrees, and then those are special angles. So when we have special angles, so we can obtain directly the we can obtain the values of all the trigonometric functions for them. So let's just review. So say for example this is theta is equal to pi over 3, now which is 60 degrees. And we know that in a triangle, if we have a 60, 90, and 30 degree triangle, so the opposite, the adjacent angle, so the opposite to the 30 degrees is 1/2 of the hypotenuse. If we have a hypotenuse of 1, therefore this is 1/2, and then here we have square root of 3 over 2. Okay, so therefore the tangent of pi over 3 is tangent is opposite over adjacent, so therefore it's square root of 3 over 2 over 1/2, so therefore it's square root of 3. Okay, so on the other hand, cosecant pi over 3, that is the reciprocal of sine. Now, so sine is opposite over hypotenuse, therefore cosecant is hypotenuse over opposite. So it's 1 over square root of 3 over 2. Okay, so this will become 2 over square root of 3, but we can rationalize that, so times square root of 3 over square root of 3, so therefore it will become 2 square root of 3 over 3. Okay, so on the other hand, if we have a theta, so say for example this is theta is equal to pi over 6, or 30 degrees. So same here, so the angle opposite to the 30 degrees is 1/2 of the hypotenuse. If we have 1 here and then 1 hypotenuse is 1, therefore its opposite is 1/2, and then the other side will be square root of 3 over 2. So therefore the tangent of pi over 6 is equal to opposite over adjacent, so 1/2 over square root of 3 over 2. So cancel this, so this will become 1 over square root of 3, rationalizing times square root of 3 over square root of 3, so we will have square root of 3 over 3. Okay, and then cosecant of pi over 6 is equal to adjacent over sine is opposite over hypotenuse, therefore cosecant is hypotenuse over opposite. So hypotenuse is 1 over opposite 1/2, so this is equal to 2. So substituting those values, so we have 2 substituting here, so tangent of pi over 3 is square root of 3 plus 8. Cosecant of pi over 3 is 2 square root of 3 over 3 minus 2 times tangent of pi over 6 is square root of 3 over 3, and then plus 8. Cosecant of pi over 6 is 2. Okay, so simplifying and then removing the grouping signs, so we have 2 square root of 3, so we have your 2 square root of 3, this will become 16 over 3 square root of 3 minus 2 over 3 square root of 3 minus, this will become 16. Okay, so simplifying, so we have the same square root of 3, so 2 plus 16 over 3 minus 2 over 3. So using the calculator, so we have 2 plus 16 over 3 minus 2 over 3. So we have 20 over 3 square root of 3 minus 16.